Emma asked her 25 classmates what they would like to have as a pet, a cat or a dog. She wrote down the results of the survey, but water spilled on her paper and she can't read one of the numbers. Help her out, please. Well, perhaps we could use a Venn diagram to demonstrate this. I'm going to let this be cat, set C for cat, and set D for dog. And we'll notice that again, I cannot say that, I cannot just put a 12 right here, right? Because these two regions together would have to be that 12, and I don't know how much is in each one. Okay, so same thing with the dogs. We don't know how many want both a cat and a dog. That certainly would be a lot easier. So we know that one don't want either. Okay, so it looks like we could perhaps use the formula we just found out, because if we looked at the union, the cardinality of the union of C and D, if one didn't want either, then the union of C and D, wouldn't that be regions? Well, I'll just go ahead and highlight it. I think that might be better since I didn't really number the regions. We're talking about all these regions right here, okay? So the cardinality there would be 24. Okay? Now we could quite easily use the formula knowing that the cardinality of the union of C and D is equal to the cardinality of the set of cats plus the cardinality of the set of dogs minus cardinality of the people who wanted both. That would be the intersection of cats and dogs. So I propose that we know this cardinality, we know the cardinality of the cats, we know the cardinality of dogs, and we don't know the cardinality of who wants both. From here it's just algebra, isn't it? So we have 24 equals 32 minus the cardinality of both. Okay, so if we subtract the 32 from both sides, that's going to give us a negative 8 equals negative cardinality of the intersection of C and D. And then dividing both sides by negative 1, I get that the cardinality of the intersection of C and D is 8. So that means 8 people want both a cat and a dog.